All right, so in this video, I want to talk about a really famous and important discrete probability distribution. And so just remember that the word discrete means we have specific outcomes that are possible that are not continuous. They're not all a range of values. There are certain things that can happen that you can count. That's what discrete talks about. And this distribution is called the binomial distribution. And binomial means that there's only two different things that can happen. It either happens or it doesn't happen. And the best example for a binomial distribution is just flipping a fair coin, where you have either heads or tails, or heads or tails. And so, what happens in a binomial distribution, let's write out what a binomial distribution is. Binomial distribution means that there is a certain number of trials, meaning you're going to repeat something a certain number of times. There's a certain number of trials, and there are only two outcomes. And those are either called a success or called a failure. And so the probability of a success is called P. And then because there's only two outcomes, all of the outcomes need to add up to 1. So the probability of a failure then has to equal 1 minus b. So let's look at our coin flip. And let's pick a number of times to flip a coin. Let's say that we're going to flip a coin 5 times. So here's our example. We're flipping a coin 5 times. And let's say that heads is our success, and then tails is our failure. It's sort of arbitrary which one you call which, but I just want to. A lot of times you'll see that language of success and failure, and it doesn't really mean winning or losing. It's just sort of identifying a way of counting up the different outcomes. So let's say we're flipping a coin 5 times, and what we care about is the number of heads that are coming. Well, there's lots of different outcomes that are possible when you flip a coin 5 times. Here are just a couple examples. You could do heads, tails, 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 heads, tails, heads, tails, heads. You could do tails, heads, tails, tails, tails. There's lots of different outcomes there. And if you tried to think about the total distribution of the outcomes, you would see that it is following what looks kind of like a normal curve, but it isn't exactly a normal curve because it's not continuous. And so what I mean by that is if I drew a graph, so I'm going to put a little dot, 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 because those are not all the outcomes. If I put a graph down here where I'm counting up the number of heads, the only possible outcomes are 0, 1, 2, 3, 4, and 5. Those are the only possible numbers of heads because I'm only flipping a coin 5 times. And on the y-axis is the probability of each of those happening. Well, there's only one way to get 0 heads. It would be all 5 of them are tails. And that happens with a 1/2 probability 5 times in a row. So 1/2 to the 5th power, 2, 4, 8, 16, 32. So this would mean that here, 0, I can represent it with a bar, and it should be disconnected from the other ones. That's 0. Here, let me do that slightly differently. Let me scoot my axis over so I can center my bar at 0. I can have a bar at 0 with a height of 1 over 32. It's the only way that it can happen. Then you think about how many ways could you have 1 head out of there. Well, there are 5 different ways. It could be the first flip, the second flip, the third flip, the fourth flip, or the fifth flip. Those are 5 different options right there. So the bar for 1 would be, and I'm not going to draw this perfectly to scale, but it's going to be 5 times taller. 5 out of 32. Now, it gets a little bit harder to draw or to count how many different ways you could have 2 heads there. One way to think about it is that you have 2 that had to be heads and 3 that had to be tails. So if you start counting them out, you can break it up into cases. So you can say, all right, case number 1, let's do it. I'm going to move my face over here. So case number 1 is your first flip is heads, and then you have 4 other options. And case number 2 is that you went tails, and then your second one is head, and then you have 3 other options. Case number 3 is that you had tails and heads like this, and 2 other options. Case number 4, tails, 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 heads, and then there's only 1 other option like that. And each of these are separate cases here. If you're in one case, you are not in any of the others. So you can add up how many total combinations there are. So there's 1 way for that to happen, 2 ways for that to happen, 3 ways for that to happen, and 4 ways for that to happen. Turns out that there are 10 total ways. So my bar here would mean 10 out of the 32 possibilities are going to be, like this. Now, the nice thing about this is once you've calculated it for 0, 1, and 2, you automatically know what the probability is for 3, 4, and 5 because it's equally likely to have a success as it is to have a failure. And so you know that for there to be 3 heads, that must be the same probability as having 2 tails. So all the work we just did to count it up is going to match it up and mirror right there, and mirror right there. Okay? So that's kind of the basic idea, is that you have a certain thing that you're doing over and over again. This is called your N, the number of trials here. And your probability of success is P. Your probability of a failure is 1 minus P. This is sort of a picture of what your distribution is going to look like. Now, I want to step back for a second and just do a couple examples where you actually calculate some things, because this was kind of hard work to come up with all of those different cases there and add them up. So it turns out that there is something called a binomial coefficient. The binomial coefficient sometimes is also called a combination coefficient. And it's the idea of how many ways can you choose one thing out of a bigger group. So for what we were doing in this example right here was we were trying to come up with all the ways of choosing 2 heads out of 5 total things. And the way that you write that, your little combination coefficient looks like this. You want to choose 2 heads out of 5. So you say, I have 5 things and I'm trying to choose 2 of them. And there's a nice formula for doing this here. 5 choose 2 turns out to be 5 factorial divided by 3 factorial times 2 factorial. The 2 numbers on the bottom are going to add up to make the number on the top. And so the way that this makes sense is 5 factorial is all the different ways you can arrange 5 things. 5 choices for the first thing times 4 choices for the second thing, 3 choices, 2 choices, 1 choice for the last object right there. So the exclamation mark just means you count down and multiply. 5 times 4 times 3 times 2 times 1. The reason that you're dividing is that some of those combinations are the same. You're choosing 5 choose 2 means you don't care when the heads or the tails happened. You just want to know how many of them there are. And if you work out what 5 choose 2 is, it turns out to be the same as what we got when we diagrammed out all of the formula, all of the cases right down there. So when you're working on problems, what you're going to do is use your binomial distribution. So if you have a binomial distribution, and the way that it'll be written is it'll use this little similarity squiggle, and it'll have the number of trials, and it'll have a certain probability. And what you can do is you can write for whatever number you care about. If you want to know, like I care about when there's K outcomes, then what you do is the probability that you get K outcomes is going to be N choose K times P raised to the K 1 minus P raised to the N minus K. And what that means is this was the number of successes you had, this was the number of failures you had, and this is the number of ways of getting that many successes and failures. So I'll show you just one more example in this, one quick example in this video, and then I'll do another video where it's all examples. So let's look at what is the probability of getting exactly 3 heads when we're looking at a binomial distribution where we have 5 tosses with a probability of 1/2 being heads. The way to do this is to do 5 choose 3 times 1/2 to the third times 1/2 to the second, because you have this is right here getting 3 heads, this is here getting 2 tails, and then this is the number of combinations, the ways of getting all your 3 heads and tails. And if you calculate that out, you can just type all that in to your calculator right here. The combinations are in your probability. So if you hit the math button on the side, there's a probability menu that you can select. So go 5, hit the math button, go over to your probability menu, number 3 down there, 5 choose 3, and then times 1/2 to the third and 1/2 to the second. Comes out to be that 0.3125. What we calculated on the last page was 10 out of 32, which is the exact same thing. Okay, so in the next video, I'll do some more examples. The purpose of this video is just to give you an overview of binomial distribution, that you're counting how many times something happens and finding the probability of a certain number of them happening.